Ever wonder what's holding our entire digital world together? You know, that invisible architecture behind everything we do online? Well, it's not magic. It's actually this incredible system for turning total chaos into perfect order. And today, we're going to pull back the curtain on that secret world, the world of data.
So let me just ask you this straight up. What powers your digital world? I mean, really think about it. Every single time you stream a movie or check your bank account, or even just like a photo, there's one powerful concept making it all happen. And that concept? Well, it's the key to everything we're about to get into.
And the answer is data. It sounds so simple, right? But at its core, data is just a collection of raw, unprocessed facts. You can think of them as individual little Lego bricks, pretty meaningless on their own, but they are the absolute essential raw material for building order out of all that digital chaos.
So, okay, how do we take those little meaningless facts and turn them into something genuinely useful? Well, that's our first crucial step, the journey from raw data to actionable information.
And this slide, this just lays it out perfectly. You start with a single number, right? 42 degrees Celsius. On its own, that's just data. It means nothing. But then you add some context. The temperature is 42 degrees Celsius. Okay, now we're talking. That's information. But here's the magic trick. The final leap is to knowledge. It's realizing, whoa, this isn't just a temperature. This is a dangerous heat wave. We need to do something. That's the whole point, right? Turning these little raw facts into actual wisdom we can act on.
And, this data comes in a few different flavors. Structured data is super neat and tidy with a fixed blueprint or schema, as we call it. A good example is your bank statement with its predictable rows and columns. Then you've got unstructured data, which is the total opposite. It has no predefined structure at all. Think a photo, a video, an email. And of course, there's semi-structured, which is that happy middle ground with a little more flexibility. There's this classic, kind of brutally honest saying in the data world, garbage in, garbage out. And man, it just perfectly captures why the quality of that initial data is, well, it's everything. If your data is inaccurate or incomplete or just inconsistent, then any decision you make based on it is going to be flawed. The whole system really relies on starting with good, clean facts, period. Okay, so we've got all this data, structured, unstructured, and it's literally everywhere. How on earth do we even begin to organize that chaos? That brings us to the next big piece of the puzzle.
The solution, my friends, is the database. And honestly, the best way to think about it is like a massive, perfectly organized library, but for data. This is not some dusty old storage closet. It's a super high-performance system designed to find exactly what you need, the very moment you need it, with incredible speed.
And this library has evolved at a really breathtaking pace. We went from writing things down in physical ledgers to the super organized tables of relational databases back in the 70s. Then bam, the internet and big data forced us to invent whole new systems for massive scale. And now, the AI era is demanding entirely new kinds of databases, like vector databases, which are designed to understand the meaning and relationships within data, not just the raw facts themselves. It's wild.
Now, a library is pretty useless without a good librarian, right? Someone to enforce the rules and keep everything in order. In the world of data, that job is just as critical.
And that librarian is called a Database Management System, or DBMS for short. It's this powerful software that acts as the gatekeeper, sitting right between you and the data. It handles all the security, it enforces data integrity, and it lets lots of people access the data at the same time without turning everything into a total mess. It's the unsung hero.
So how does this DBMS guarantee absolute reliability, especially for something super critical like a bank transfer? It uses this strict set of rules known as ACID. So atomicity means the whole transfer either succeeds or it fails completely. There's no halfway. Consistency makes sure the books always balance. Isolation means two different transfers can't mess with each other. And durability? Well, that just means once your money is sent, it is sent for good.
But, in tech, there's always a trade-off. Always. So to keep your data perfectly clean and error-free, a process called normalization, you split everything up into tons of tiny logical tables. It's great for accuracy, but boy, can it be slow. So what do you do if you need speed? Well, you do the exact opposite. It's called denormalization. You basically mash some of those tables back together, even if it means you're duplicating some data. It's this constant tug-of-war between speed and perfection, and trust me, it's a choice developers are making every single day.
All right, enough with the theory. Let's actually look at where these powerful, organized systems pop up in our everyday lives.
Yeah, we just touched on it, but banking is the perfect example. Every single transaction, every fraud alert, every stock trade, it all relies on databases where that ACID consistency is completely non-negotiable. There is just zero room for error.
None. And think about when you shop online. Databases are working overtime in the background. They're not just keeping track of inventory, they're analyzing your past purchases and what you've clicked on in real time to power those sometimes eerily accurate, you might also like recommendations.
And what about social media? I mean, platforms like Meta use these specialized things called graph databases. Instead of tables, they think in terms of nodes, that's you, and edges, which are the connections you have to friends, pages, and posts. It's really the only way you could possibly manage that mind-boggling web of billions of relationships.
And yep, this brings us right to the AI revolution. Modern AI models are trained on these unimaginably huge data sets. And where do you think all that data is stored, organized, and accessed from? You guessed it, highly specialized databases. They are the silent, unsung foundation of pretty much all modern AI.
So the systems we've built are absolutely incredible, but the world of data never, ever stands still. So what's coming next?
Well, the biggest shift happening right now is this sort of battle between two philosophies. On one side, you have the traditional relational world of SQL, which is all about that perfect ACID consistency we talked about. But on the other side, you've got the modern web-scale world of NoSQL. These databases were built for flexibility and massive scale, prioritizing availability, something called base, even if it means giving up a tiny bit of that immediate, perfect consistency.
And the future? It's even more wild. We're talking about autonomous databases that can literally tune and repair themselves. Databases that live right on your phone or your devices at the edge. And the continued rise of vector databases built for truly intelligent AI-powered search. The library isn't just getting bigger, folks. It's about to get a whole lot smarter. But of course, with all this incredible power comes some immense challenges. We're in this constant battle with cybersecurity threats. We have to navigate super complex regulations and break down these annoying data silos between departments. And really critically, we have to make sure that data itself is high quality and actually represents the real world to avoid bad, biased results. These aren't just technical problems, they're the major puzzles we have to solve going forward.
Which brings us to a final, really crucial question. As these systems become more and more intelligent, as they start to manage themselves, they're going to start learning from our data. So the real question for the future isn't just a technical one, it's about our intent. What problems do we want them to solve, and what values do we want to build into the very foundation of our digital world? Something to think about.